All right, the next thing that you might have to do is, instead of being given the half reaction, so in this case, the half reactions were given to you, you just flip one and you calculate. What if they just gave you the species? You have to find the half reaction, create the half reaction, and then go from there. So let's do the first one. I'm going to show you a table, what a table of reduction potentials looks like. This is right off of an old AP test. Manganese has a couple. In this case, they would tell you which one to use, so we're going to use that one here for manganese. And then we're going to use iron 3 plus going to iron 2 plus here. Okay. All right, so I'm just going to write them out in terms of their reduction first. So I've got MnO4 minus plus H8 plus 5 electrons goes to Mn2 plus 4 waters, and it's 1.51. Then my other one is Fe3 plus E goes to Fe2 plus, and that is a plus. I'm going to put pluses here just to emphasize, 0.77. All right, now problem we have, they're both reduction. We look at these two and we say, okay, which one am I going to flip in order to get this to go? I can't flip this one because then I have a negative 1.51, which makes the whole, when I add them together, makes it negative. So I'm going to flip this one, and I have to multiply by 5. So I'm going to multiply by 5 and flip it. So that's going to be 5 Fe2 plus goes to 5 Fe3 plus 5E. Remember, I'm not going to multiply this by 5, am I? I'm just going to make it a negative 0.77. Okay? Now I've got all those cancel, and I put all that together. MnO4 minus plus H8 plus 5 Fe2 plus goes to Mn2 plus 4 waters plus 5 Fe3 plus. Okay, not too bad. Let's do the next one. All right, I'm going to do it in the same way. I'm going to go to my tables. I'm going to find these two redox reactions. All right, so I'm going to go here. This is a really good one to look at because here's what I'm interested in, NO3 and NO. Notice that there are no metals here. Remember that other elements can be oxidized and reduced. So in this case, I have this reaction, and I've got copper, and that can suffice as an oxidation reduction reaction. So don't be surprised if that happens. You may not always have a metal in your half reaction. So here we go. I've got NO3 minus plus 4H plus 3 electrons. Let me make a line here so I don't get them confused. Goes to NO plus 2H2O, and then I've got copper 2 plus 2 electrons. So I'm taking these right off my standard reduction tables. I know there's a quicker way to do this, but I would recommend writing it all out so you don't get stuck. All right, now this one's is my potential is 0.96. This one is plus 0.337. So when I look here to see which one to flip, we definitely don't want to flip this one. We're going to flip this one because when that becomes negative, that'll work. Now, what we're going to do, let's start with this one. We're going to flip it, and we also have to multiply by 3. And this one, we're going to have, oops, not over there, right? We're going to have to multiply that one by 2. So let's tackle this one first. We're going to multiply it by 3 and flip. So 3 Cu goes to 3 Cu2 plus 6 electrons, and that gives a negative 0.337. So I'm going to cross that out. Then I'm going to multiply the top one by 2 only. 8H plus 6 electrons goes to 2NO plus 4H2O. Again, I leave this alone. So this is going to be a positive 0.96. My electrons all cancel. And my final thing is copper plus, this should be 3, sorry about that, 2NO3 minus plus H plus goes to 2NO plus 4H2O plus 3Cu2 plus. And I add these two together, and my voltage turns out to be 0.623. So let's put, so there's a lot of work for that problem. So let's put that there. I get 0.739, 0.623, and I want you to do the next one. You should get a 1.66. The final reaction for this one will be 2 aluminum plus 6H plus goes to 2 aluminum 3 plus 3H2O. I want you to go ahead and see if you can do that one.